I'm an applications engineer at Agilent Technologies supporting signal generation solutions for the wireless connectivity markets. The IEEE is developing a new standard for wireless LAN called 802.11ac that uses up to 80 or 160 megahertz of bandwidth and higher order modulation up to 256 QAM. This new standard enables end users to achieve higher data rates to support services like high-definition video and simultaneous data streaming. Because of the wider bandwidth and higher order modulation schemes, engineers face new challenges in designing their 802.11ac components and devices and testing the RF performance. What you will learn in this video is how Agilent can help meet the challenges of designing and testing 802.11ac devices and components. Our wider bandwidth, higher performance test solutions will give you the confidence that your components and devices will meet their demanding specifications. Our setup today includes our new N5182B MXG X-Series signal generator, the N9030A PXA signal analyzer, and on our PC we have the N7617B Signal Studio for wireless LAN to create our waveforms, and the 89600 VSA software to analyze the results. The Signal Studio and VSA software can also be installed inside the signal analyzer to eliminate the need for an external PC. To demonstrate how quickly and easily we can create a 160 megahertz signal, we will use Agilent Signal Studio software, which has been recently updated to include 802.11ac functionality. We've set the center frequency to 5.57 gigahertz, which is one of the 160 megahertz channels supported by 802.11ac. I've also selected the bandwidth of the signal to be 160 megahertz. Only Agilent supports generation of signals with 160 megahertz bandwidth in a fully integrated source. There are additional settings available for configuring parameters for MIMO, as well as other customized signal settings. Here is where you can configure your data packets. We can increase our payload data so that we can have more symbols to analyze. This is also where we set up our modulation type. You can see here where we have set it to MCS 8, which is 256 QAM. Our signal is now being generated here in the MXG, and we will use the PXA signal analyzer and our VSA software to analyze the results. Here is a display of the demodulated 802.11ac measurement. We can now see the 160 megahertz span of our signal and make additional measurements, including EVM. On our EVM measurement, you can see that the value is minus 47 dB, which shows the exceptional EVM performance of the MXG. We can also look at the measured IQ errors of our signal and see that they are very small, resulting in the excellent EVM result. As I've just shown, Agilent's solution will help you test your 802.11ac components and devices throughout the product lifecycle, from design verification to manufacturing. Agilent is the only test equipment provider with an RF signal generator that supports flat bandwidth up to 160 megahertz with excellent EVM performance. For more information on Agilent's 802.11ac test solutions or our new X-Series signal generators, please visit our website.